All right, so if something is a factor, so if I take a number and divide it by a factor, for example, if I take 12 and divide it by 4, I get exactly 3. I could say that 12 is the same as 3 times 4, and there is no remainder. So given that my polynomial can be expressed as quotient times divisor plus remainder, if this is a factor, then my quotient times my divisor is going to equal the polynomial exactly, so P of B must be 0. So if the remainder is 0, or if P of B is equal to 0, then x minus b must be a factor. So let's come down here and determine, these shouldn't be binomials, which binomials are factors. All right, so if it's a factor, then for this case, f of 2 would equal 0. So f of 2 is going to be 8 minus 24 plus 6 plus 10, and I get 24, that's going to be 0. So then x minus 2 is a factor. All right, if I put in 3, so f of 3 is going to be 27 minus 6 times 9 is 54, plus 9 plus 10, 19 and 27 definitely does not equal 54. So x minus 3 is not a factor. F of negative 1, let's see what we're going to get here. Negative 1 minus 6 minus 3 plus 10, that does equal 0. So x plus 1 is a factor. All right, already I know x minus 2 and x plus 1 are factors. So knowing that, I could multiply them out and get my quadratic, which I could then divide. I could also use my synthetic division to test. So I could plug in 5, but I don't want to have to do 5 cubed minus 6 times 5 squared. So instead I'm going to use synthetic division. So I know that 2 was a factor. So 2, and then I've got my 1, negative 6, 3, 10. So 1, 2, negative 4. That's going to give me negative 8, negative 5, negative 10, remainder 0. Now that tells me that x minus 2 times x squared minus 4x minus 5. Well, so x minus 2 times x squared minus 4x minus 5 is going to be x minus 2 times x minus 5 times x plus 1. So in this way, I know that x minus 5 is a factor also. Once I know all those factors, I also know that 10 is my y-intercept. So I could graph this. I know that x equals 2 is an intercept, x equals 5, and negative 1. Those are all my roots. It's cubic with a positive a value. So we come up somehow, down, and back up.